Hi. So today we're going to learn how to do two things. We're going to learn about how to write a file to your computer. As well, we're going to learn about these handy dandy using statements that you see. So we're going to make a new project, and let's call it IO Write. I'll call it Iowa lesson. IO means input to output, and you can output to a file, you can input the file, you can output data, input data. That's why they call it IO. So let's wait for our project to be completed here, or created. Okay, so here we go. We want to be able to write something to a file. So let's make a string variable. We'll make a string called stuff to write. Okay, so we have a string variable called stuff to write. So let's see here. We will be initializing it. So stuff to write is equal to console.readline. And of course, because it's a method, we always put these parentheses here. So we've made a variable called that's of type string, and we're setting its value to whatever the user entered. Now, what I'm going to do is we want to write a file. We want to write a file. And what do we want to do with this file? We know we want to make one, but what do you think we should put inside of it? What we're going to put inside the file we're creating is what the person wrote. So we are going to type in using. So this means that we are going to be using something and trashing it once we're done. However, this iteration of using is not the same as how using is used up here. You're about to see how it's used though. So if we want to write something to a file, particularly a string, we are going to use stream writer. And we're going to say stream writer, let's call it SW, is equal to new stream writer. Let's compile that. What's wrong with the code? Okay. It says that the type or name streamwriter could not be found. Are you missing a directive or an assembly reference? We are. We are missing an assembly reference. These using statements reference different assemblies. Using system references stuff that the system has. System.collections.generic is an assembly reference to some other stuff. Using system.link, the same thing. If I get rid of all of these, let's see how many things are missing. The name console does not exist in the current context. Why does it not exist? The assembly that those using statements were containing contain different classes and methods. Because we're missing that, it's going to say that, hey, nothing exists here. This thing you just told me about, it doesn't exist. So we have to resolve it. We right click it, we go to resolve, using system. Our console.readline's fixed. So, now, our stream writer, we want to resolve it and use system.io. So up here it says using system. This gives us a whole bunch of classes as well as a console.readline that we're using. So using system has the class console inside of it. Using system.io has a class StreamWriter inside of it. So now that we have these two, it's not complaining, everything's okay. However, I also got rid of a little too much here. So let's see. System.io.StreamWriter does not contain a constructor that takes 0 arguments. StreamWriter can contain multiple things. You can pass it a stream, which I'll get into later. But a stream basically is something where you can write data or read data from. You can write data to a stream, you can read data from a stream, whatever you want. In this case, our StreamWriter writes data to a file. So we have to tell this what we want to write to. We could write to a stream, but we want to write to a path. If we write to a path, we write to a file onto your hard drive. When you write to a stream, you're writing something to memory. So let's go over this. If we write a string path, we're writing to the computer. If we write to a stream, we're writing to memory. For now, we'll just worry about writing to a file. So let's type in the path we want to save it to. What we're going to do is we're going to type in application. Oh wait, no. We can't do that. So, where do we want to save this file? Where do we want to save this file? We need a path name to give this. So, let's go to our desktop here. So we have our desktop. I'm trying to get the path to that, which I am not finding. Okay. Here we go. So we'll do the C users and whatever your name is, your profile name is here. Or you know what? Let's go simpler. Let's just type in what we want the file name to be. Doing what I'm doing right here is a bad practice because you're assuming that basically the program's making an assumption of where you want to save the file. And it's not going to save to where you expect all the time if you don't give an exact path name. What I'm writing here is, I'll just call it I'll call it written stuff.txt. So we're going to expect that this is going to be beside our executable. Expecting. It could get saved to another path if you start going around and exploring, navigating stuff. And it's complicated to explain why this is a bad practice and how it really foo-bars everything up. Most of the time it will be where you expect it to be, and then most of the time it won't be writing to where you expect it to be. That's only in this instance because we're assuming that it's going to be beside our executable and we're not giving an exact path name. We're just saying, write a file called writtenstuff.txt. Write it wherever the heck you want. Write it wherever you want. We just want you to write it. So it's going to be in a random place. In most cases it's going to be beside our executable. In other cases it won't be. So let's compile. Control-Shift-B. We are missing a bracket. Or no, crap, I forgot what it's called. Okay, so it says possibly mistaken empty statement. Oh yes, we were missing a parenthesis, right. So possibly mistaken empty statement. So what we are going to do is we're going to write SW dot right line, and we're going to have it do stuff to write. So let's enter something into here now. Let's type in some gibberish and say this is a test, and it spelled that incorrectly. So if we navigate to our project, which we called it IO lesson, or it's going to be whatever you've named it. There's now a text file here called written stuff. And exactly what we wrote into the console window, it's over here, it wrote it to a file. So you've made a variable called stuff to write. It's of type string. We then set the value of the variable stuff to write to whatever the method readLine returned to us. And then we then put a using here. So it's saying, okay, we're going to temporarily use this. And once we've done executing code here, we're going to destroy everything that happened here. What happens if we don't use a using? What happens is we would have written to a file, written what we were told to write, but then no other application could access the file because it would still be open in this program. So by using a using, it says, okay, let's temporarily open this up. Okay, write a file, write some stuff to it. Okay, we're done with the file. By using a using statement, your program will say, okay, I'm done with the file now, once it's done doing what it needs to do. If you don't use the using statement, you could be done with the file. You know you should be done with the file, but the program will say, nope, you cannot touch this file, I'm still using it. The person didn't tell me not to use it once it was finished, so it's mine. Don't touch it, you can't touch it, I'm using it. So you use a using statement to let the program know that you no longer need the file once it's done executing the code inside of it. So that's how that works. Now, this is pretty much everything we've done. We have two using statements. System.io allows us to use StreamWriter. Without that, the class StreamWriter does not exist. So we have to have a thing saying that we want to use the classes under System.io. System.io. And then StreamWriter works. Here we entered a path name. Very vague though. We said, write a file called writtenstuff.txt. Let's change that to written stuff. So we said, write a file called writtenstuff.txt. Although, we don't care where you save it. Just save it. Because we didn't tell you where to put the file. We just want you to write the file where you think it's best to put it. You may be completely wrong, but we're trusting that you're going to put it in the right spot and it will be there. Most of the time it will be where you expect it, but most of the time it won't be, if that makes any sense. If we can, let's try putting in a hardcode path name. So we're in our project here, we'll actually give it a correct path name. There. Now the operating system doesn't have to guess. Now we have errors here. Why is it that this is complaining? We've typed in a path name, we told it where to put it, but it keeps saying unrecognized escape sequence. Why? Well, with strings there's these things called escape sequences. They do different things to a string. We'll get into those later on, but normally what you do to correct this is you double line each slash so that compiler knows that, okay, they're not trying to do an escape sequence, they want to do a path name. Or, the quickest way to do it is put an @ symbol at the beginning, and it will tell the program, you know what? Everything here, there will be no escape sequences. I promise you there is no escape sequences. So don't look for any. Just write this path name. There are no escape sequences. I've told you there are none. I don't plan on putting any escape sequences here, so I put this @ symbol here for a reason. That's what you're telling the compiler. You're telling it that you will not be putting escape sequences in your string. Assume that all slashes are just the next folder you want it to navigate through. So, let's compile this. And we will write something. We'll write, hello world. We are writing a file. Okay, program did its stuff, it closed. And we'll go to our written stuff.txt. It says, hello world, we are writing a file. Now let's do another thing here. Wouldn't it be convenient if the file we just wrote opened up for us? Wouldn't that be convenient? It would be nice if after we've written the file, we don't have to go through Explorer and find the text file that our program wrote. Why not just have it open it up right in front of our faces? Well, we can do that. We will by using a method called process. Oh. Okay. What's wrong here? Process doesn't exist. But this is a class I want to use, but it doesn't exist. Well, we know process is a class that we can use, but we have to resolve it. We have to right click it and use system.diagnostics. Now we can use the method called process. So here's something that's going to confuse you guys. Remember when I said when you're using a class, you have to make a new instance of it? When you make a new class, you assign it a variable to it, and it has to be equal to a new instance of that class. Process is not one of those classes. Process acts as if it's both a class and a variable at the same time, in a way. Really, it's a class, and you don't have to, and there is no instance of it. Why? Why do you not have to make a new instance of process? Why? Well, let's go to definition. And it will explain it right there. And that tells us absolutely nothing. So, all we know is that this is one of those classes that doesn't need to have a new instance to work. So we're just going to type in the application we want to run. What we are going to do is, we want to open this up in Notepad. So we're going to say Notepad .exe, and then we're going to give it a string argument. And our string argument is just going to be a path name. So what we're doing is we're going to open up Notepad, And we're also telling Notepad to open up this file. So, later on we'll get to having our own programs, except things like command arguments. Because if you notice here, our main method does have the ability to accept an argument. That's why we have the string args here. When your application is launched, you'll either be launched with no arguments or a null argument, or it will be given an argument with the path name. And it's up to your program to do what it wants with that argument. In Notepad's case, Notepad knows that if it's passed an argument, it should be a path name, and it will open that path name argument. So let's run the program. So let's type in whatever we want, some gibberish. And press enter. Here we go. So it opened up Notepad. Our program's closed, but it opened up Notepad, and also opened up this file within Notepad. So we went over a few different things. We went over how to essentially what these using statements do, and how they're important, and how this using statement's different, how it trashes, it disconnects everything once it's done doing what it needs to do. And we also have this here where process.process is a class that doesn't need a new instance. So we call a method inside of process called start, and start's method says, okay, I accept 1 or 2 arguments. So if you just give me the application, I will open up the application. But if you put a comma here and give me another argument, then I'll open up Notepad with this information here, so that Notepad knows that, okay, I've been started up. Oh, I have a command line argument. I should probably open up this path name the person gave me. So that's what that does. So that's just about everything here. If there's anything you don't understand, maybe I explained poorly, or if I'm doing this too fast, just let me know, and I'll go back into this with more depth, different explanations, different analogies, stuff like that. And I hope you guys keep watching, and I'll see you guys later.